So the activity this week is we're going to look at how to form a scientific question. And one of the questions will be, what's the difference between a scientific question and a normal question? Well, there's a fairly easy answer to that. Your scientific question needs to be testable. So you have a question, you've got to be able to test it. It's got to be measurable. So whatever question you come up with, you've got to be able to measure something to come up with the answer. It's got to be repeatable. So you've got to be able to repeat it again and again. And you need a control of some description. So today we're going to come up with a question, and we're going to repeat it's going to be a testable question, and we're going to repeat the test 3 times. And that's why I'm making 3 sandcastles. Now you can do this at home, and in fact this is your activity to do this. I'm just going to display it for you. Now, depending on where the camera is, you may or may not be able to see this, but I've now made 3 small mountains, sandy mountains, of exactly the same size. So to do this one, you're either going to need some sand, or you could do it inside if you had some flour and have it inside in a container of some type. And what you're going to need to do is you're going to need to be able to make 3 mounds. You're going to need 3 identical amounts of water, and you're going to need a ruler. So the reason I've got 3 is because I'm going to repeat this 3 times. The reason I've got a ruler is because whatever question I come up with is going to need to be measurable. And what we're going to do, my question is going to be, does the flow of water affect the amount of erosion that happens? Now, I spent the last few minutes sort of showing you how that's probably going to happen, but we're going to test it for sure. So does the flow of water affect the amount of erosion that happens? Now, I'm not testing the amount of water, and I've kept the amount exactly the same so that we don't have too many other things going on. So we know it's not the amount of water I'm putting on, we're looking at the flow of water, so how quickly the water pours. And what we're going to need to do is for each one of my hills, I'm going to need to measure, so that one's 110, and you shouldn't write your data down in the soil like I am, you should write it on a piece of paper. That is much better science. Yep, this one's also 110 millimeters, that is, on a ruler. You don't need a big ruler like this, just your normal 30 centimeters school ruler will do. And this one, yep, is also 110. So my question is, does the flow of water affect the amount of erosion that happens? And so I'm now going to go, okay, one by one, I'm going to get some water, and I'm going to pour it on. And then I'm going to grab the other glass and pour it on here, and grab the other glass and pour it on there. Now, for me, what I'm going to do is, I've measured it, the height it is now, for each of them. And after I've poured the water on, I'm going to measure them again and see if there's a change. So my question is measurable, because I'm going to measure the change in height of my little sand mountains as a measure of how much they've been eroded. And it's repeatable because I've made these exactly the same, and they must be exactly the same because we're trying to reduce variability. And I'll probably talk more about variability next week as we look at other scientific measures and other scientific questions. So we're trying to keep it every repeatable step, we're going to try and keep exactly the same. And the reason I've made 3 separate mountains is because if I did one mountain and then rebuilt it and then did it again, it's not going to be the same, because then this mountain's going to be really wet. And so it's not really the same, is it? But at the moment, these 3 mountains have the same amount of wetness. So my first step is I'm going to carefully pour some water on this one. Just carefully, so the flow's not too bad. It's raining, but it's raining lots, and we go, oh wow, yeah, yep, that's definitely eroded. So I've done one. I'm going to measure the change in height of my mountain, and it's gone from being 110 to it's now a height of 90. So we eroded 2 centimeters off that, or 20 millimeters off that, and that was just a nice slow rate. And I probably could have timed that rate and gone, yeah, it's going to take me 10 seconds to pour that on. That would have been better if I'd timed it. Now, this one I'm going to go even slower and see if that makes a difference. Now, I'm going to count it out this time. I'm just going to 1, 2, I'm going to go for 20 seconds. 3, 4, 5, 6, 7, 8, 9, 10. And you can see there's a couple of other things happening here about how well the water pours. 13, 14, 15, 16, 17, 18, 19, 20. So that was a much slower rate. So that was the same amount of water, slower rate. Let's see if that made any difference. Oh, to be honest, that one's at about gone down 100. So a much slower rate at first test. The slower rate, it's only worn it away by 1 centimetre. So going slower, same amount of water going slower, seemed to erode it less. Now, we've got our last one to go. Now, you can probably imagine what I'm going to do with this one. We've poured it out over 10 seconds, poured it out over 20 seconds. This one, we're just going to slam it down, and I'm going to try not to get wet as I do it. And we're going to see what that does. So, now we've done 3 replicates here, but we have changed something, haven't we? We've changed the rate. And we want to see if the rate makes a difference, but really we should have done 3 of these all at a rate of 10 over 10 seconds. 3 of these ones all at a rate of 20 seconds. And 3 of these ones. But I'm just demonstrating how we can do it. Okay, are you ready? I'm just going to pour it out. I'm going to try not to get wet. We're going to try that again. And I want to actually hit it correctly this time. Okay, now this time I'm going to actually try and hit the mountain. Okay, take 3. I'm going to try and hit the mountain. Alright, got it that time. Let's measure it. Right. Now, if we're absolutely honest, that one only got eroded down to 105. So it only lost 5 millimeters, even though it was a sudden burst of water over the top. Now that tends to suggest that one's the one that got eroded least out of the others. Now, I guess when we look at it, that's going to tell us a few things. Our first one got eroded the most over when it was being poured out for 10 seconds. Our second one got eroded in the middle, and that was poured out over 20 seconds. And the last one that I actually would have thought would have eroded it the most didn't. So it's quite interesting. And this is why we do these experiments, because sometimes what you think is going to happen actually doesn't when you experiment with it. Now, if this was going to be a good, full scientific question, I would repeat all of these another 2 times each. So I'd do this one 3 times, this one 3 times, and this one 3 times. And that would mean we've tested it appropriately. We can't just do it once. And if we want to look at the variability of something, like we have here, we've looked at change in something, we've got to do, each time we change it, we've got to do it 3 times. We also need something that's called a control. Now, clearly these changed because I poured water on them. But if we're going to be scientifically accurate, we need a mountain that we do nothing to. We need one here the same size and shape, and we need to do nothing to it, because for all we know, something might have happened that we didn't see that caused a change in these things. So we would have measured this one at the start, we would have then turned around and measured this one again at the end, just to make sure that nothing happened that we hadn't seen to cause the mountains to go smaller. And I know that seems a bit silly, but it's also really important, because sometimes in science there'll be something going on that you can't see, that you wish you'd had a control to make sure you'd measured it. So our scientific questions need to be testable, they need to be measurable, they need to be repeatable, and you always need to have a control to make sure that there's not something that's gone on that you didn't notice that's happened to affect your results. And this one we wouldn't do anything to, and we'd measure it at the start when we measured the others, and we'd measure it at the finish, the same as we measured the others. So you guys can have a go at something like this at home, like in your own sandpit if you've got one, or you can just do it in a tray in the kitchen with some flour, like do a mini version. Hopefully you're a bit more accurate with your water throwing than I am. And you'll need a ruler, you need some water, and you need to make 3 identical hills. And that's today's activity.